Hi, we all have used ChatGPT, right? So, where does this data in ChatGPT come from? It comes from LLMs, and who populates data in LLMs? The web crawlers. So, in this video, we'll dive into the system design of web crawler. So, web crawler are essentially tools who gathers information throughout the internet from search engines to these LLMs. So, let's get started. Let's start with our functional requirements. So the first functional requirement is crawl the seed URLs. Assume we have a list of URLs whose web pages are supposed to be crawled. So these are the seed URLs. Now these web pages, when crawling, we need to extract text data, which is our second point. And while extracting the text data, we need to keep into consideration politeness. Now what politeness is, which is our third point. So politeness is to adhere to robots.txt file. Now what robots.txt file is? It tells search engine crawlers which URLs the crawler can access on your site. This file is basically present in your web application or your website and so on. This is used mainly to avoid overloading your site with requests. And after extracting all this data from the web pages, we need to store it somewhere, right? So we need to store extracted data efficiently, which is our fourth point. And our fifth point says we need to implement basic error handling and retry mechanism. Moving forward to our non-functional requirements, the first one is we need to efficiently crawl and extract data from a large number of web pages. Now these large number of web pages can range more than 1 billion web pages. So, and the second point is we need to support horizontal scaling by adding more crawling nodes. So how can we decide the number of nodes? And why should we horizontally scale the system is what we are going to see in our video. The third point is to avoid recrawling to the page if page content is not updated. This is basically to avoid duplication of the content. Let us start with the high level design of web crawler. So what a web crawler service is supposed to do. So the web crawler service is supposed to crawl the web pages. So how will it crawl the web pages? How will it get to know that what web pages are supposed to be crawled? From the URLs of those web pages, right? So it need to get the URLs. So let me write it down here. Number one, gets the URL, and number two, fetch the pages from URL. Right, so these are the two things that a web crawler is supposed to do. Now, where will it get the URL from? So it will get the URLs from URL Frontier. So now what URL Frontier is? So URL Frontier is nothing but a queue which maintains the URLs and sends them in some order whenever a web crawler seeks a URL. So this is a URL Frontier. Let me write it down here as well. Right, so this is what a URL Frontier is. Now after getting the URL, definitely the web crawler will go to that particular web page, and after going to that web page, it will get the HTML of that particular page. So after getting that particular HTML, what it will do is it will store the HTML in S3. Let me write out here, S3. Will store HTML pages, and the page whose HTML is stored in this S3, so it would be stored somewhere, right? So that storage location would be sent back to this web crawler. So it gives the S3 link of particular page, right? So this is how the web page would be stored in S3, and the web crawler will be getting back the S3 link of that particular page. So these S3 link which our web crawler got would be further passed into a queue A queue here, Amazon SQS can be used or Apache Kafka can be used. So Amazon SQS is a simple queue service. It is easily configurable compared to Apache Kafka and can easily integrate with other Amazon services like S3 we are using here. So yeah, so the S3 link would be passed further to this queue. So these S3 links added to queue would one by one go into parsing service. So what a parsing service here is? So a parsing service will do three steps. One is it will get HTML from S3 link. So we have stored the HTMLs in our S3. So we'll be fetching out those HTML from that particular location or through the S3 link, and then we would extract the text from that particular HTML and would save those text again in S3. So we'll be saving two things in S3. One is the HTML pages and the other one is text extracted out of those. After extracting the text, would be also extracting other URLs. For example, let's say if your web page has a contact us page or about us page or some other web pages which are linked through that particular web page, right? So those URLs would be extracted out here, and after extracting those URL, we would be sending it out here again back to the URL frontier. It may happen sometime that let's say there's a URL whose web page is not reachable because let's say there's some issue with the web page or the website is not up right now. So what we can do is for those URLs, like we need to set some threshold. Let's say if we are setting 3, then that particular URL would be processed 3 times. If all the 3 times it is not reachable, then we'll add it in failed URLs DB, and we'll can further discuss with our product manager and so on that these are the failed URLs and what can we do about it. Also, we can reschedule it in the frontier, which would be reprocessed further. Let's talk about politeness now. So how will we implement politeness here? Like we need to adhere to robots.txt file, right? So in that particular web application, there would be some properties such as let's say crawl delay or user agent or disallow in robots.txt file. What they mean, like let's say crawl delay. So if you have a crawl delay of 10 days mentioned, then if you have crawled the web page today, then till 10 days you can't crawl that web page. Then let's say there's user agent mentioned. For example, let's say Google bot is being mentioned in user agent, then all the set of rules below that would be applied to Google bot. Then disallow is mentioned. So let's say there are some web pages in that particular website mentioned in disallow, or it can be private as well to not allow it to crawl. So these are some properties that robots.txt has, and let me show you how we can implement it here. So what we can do is we can have a database, and in that database, let's say we have a table or let's say collection named politeness. And what would be the fields out there? There must be a domain to identify the robots.txt and its properties. We can have the last crawled time. Then we can have a crawl delay. Last crawl time, to know that what was the last crawl time and when next is it supposed to crawl and when it can not crawl. Then comes user agent, then comes disallow, and so on. So these could be the properties here in the politeness table. So we'll store it. So whenever the URL gets hit, it will go to the robots.txt file and it will check it out. It will check the domain whether when it was last crawled and is it supposed to crawl now, or what are the sets of rules for a particular user agent, or which web pages are not allowed. And to identify domain, obviously we can use a DNS. Let me edit out here. Yeah. Also, we need to avoid duplication, like duplication in terms of the web page content being crawled. Like let's say if there's a web page whose content is not changed over years, and still we crawl it every time, then it may consume some time and it may use resources as well. So we want to avoid that. We want to avoid those duplicate efforts if the changes are not made. So what will we do? So we can do one thing, that whatever here we are getting the HTML, right? So we can hash the HTML file. Let's say we can hash HTML in our web crawler, and after hashing this HTML, what we can do is we can add one more table here. Let's say a URL table. So in this URL table, what we can have is, let's say, URL as a primary key itself, because it will be unique. Then we can have the HTML hash. So this hash HTML, we would compare each and every time that is it same. So if it is same, then and only then we will add it to this queue and we'll pass it to parsing service. Otherwise, we won't let that URL being added to this queue. So this is how the web crawler works, and all those text data which are being extracted and stored in S3 could be further used in the LLMs. Let's now discuss scalability. So assuming that we have 1 billion web pages which we need to crawl within a 7-day period, and the average page size we can consider somewhere around 2 MB including media, out of which the text content can come out somewhere as 25 KB. So the total text data size could be 1 billion pages into 25 KB, which comes out somewhere around 24 terabyte of raw text data. Also, the crawling rate, we can consider it approximately 143 million pages per day. This comes out from dividing 1 billion web pages by 7, and if we convert it to pages per second, we get it as 1653 pages per second. So to crawl 1 billion pages in 7 days, we need to process about 1653 pages per second. And if we assume that each node can process 100 pages per second, then the nodes we would require is somewhere around 16.5 nodes. Now there could be some potential failures, there could be some load variations, or if we need to ensure some smooth operations, we should consider some extra nodes as well. So the final estimate can come out as 20 to 30 nodes that we can use for horizontal scaling of web crawler. So yeah, that's it. That was all about web crawler system design.